All right, now let's take a look in this video about how we can do translations in GeoGebra. Okay, so there are a translation. You have to specify a vector to identify which translation you're talking about. So you're translating by a vector, and then of course you need to identify a pre-image point or set of points. So let's start by just taking a triangle for our pre-image. And it can be any triangle we want, so we just made a free triangle, but it's probably best if we make a scalene triangle so you can kind of see what happens with it. Okay? Now, we need a vector. There's several different ways to get a vector. One of them is to just use this vector tool here, and we draw a vector. It could be anywhere. So that we got that vector D to E. So we want to translate this triangle by that vector. So how does that work? Well, let's just take one point at a time. And there's a command for that. It's right, your transformations are all right in here. So these are the main ones. There's reflect about a line, rotate about a point, translate by vector. Those are your three main transformations. And then you've got another one that's not an isometry, dilation from a point, and a couple other type of transformations we can talk about a little bit later too. Okay, but right now we're focused on translation. So that would be translate by vector. You first select, right here it tells you, select the object to translate, then the vector. So we can select this point, and then we can click on this vector like that. And notice that if we do this vector right here, it is actually the same vector as this vector here. And geometrically what's happening is these two line segments are congruent and parallel, so that makes a parallelogram right there. Now, I think we can, let's see if we can do this. I think I can go here and select a whole bunch of stuff at once. So I think I can say translate by vector, right click and highlight all of this, and then click on the vector. Yep, took the whole thing. So notice that they would typically put primes on these guys. Usually this will just be called A prime, B prime, and C prime. I'm not sure why we got, oh well, it's because they're actually doing multiple points here. There's the original C that it translated, and then the one at the end of each of the line segments, I guess. I don't know why it's got so many different ones. We can hide these multiple copies of that, and just have the one copy of it. Okay, so then the image points are A prime, B prime, and C prime of A, B, and C respectively. And once again, each one of these vectors right here is parallel and the same length as the original one up here, so they are all the same vector. Now here's something I like to do when I'm dealing with this. I usually like to take the original figure, and I like to just use blue just to keep things the same color every time. So that's the pre-image, and then I like to make the corresponding image red. Okay, or you choose your own colors, but it's useful to use the same colors there, so you get used to seeing pre-image in blue and image in red. And the vector that we have here, this one, this one, this one, and this one are all the same vector. Oh, how about green for that? Okay, and now notice that this is controlled by this vector here. So as we move these points, you can see it. So you can actually see this in motion now as we move from the tip, from the tail to the tip. You can see it being sliding around. So you can see it actually in motion being translated around. A translation is the easiest kind of transformation to actually kind of convince yourself that it is an isometry, because it is just simply taking the same figure. It's got exactly the same orientation as before. If we were to go in here and to look back here and show some axes or a grid, maybe show a grid lines there. All the slopes are staying the same relative to the background. It's the same. Let's just take the axes off. We just look at a grid like this. Everything is looking exactly the same way. Let's make this go with some lattice points here, like say here and here. Make the original one to have the lattice things here. And now we can see that on the grid, we can see the vector is going to the right. 1, 2, 3, see, 1, 2, 3, 4, 5, 6, 7 to the right and down 2. So every single point is going 1, 2, 3, 4, 5, 6, 7 to the right, down 2. This is going 7 to the right, down 2. This is going 7 to the right, down 2. And as are any other points, any other point that we have on this line segment, it's going to be going there as well. Let's do that. So let's take a point here, say on line segment AC, and translate it by that same vector. And once again, here's the copy of the vector here to here. And if we're staying with our color coding, this is an image point. It's red. That's the same vector. It's our green color. Okay, so now what do we have here? It doesn't matter where this is. All the points, infinitely many points in between, their images are going to stay between the image points of the endpoints. So A goes to A prime, C goes to C prime, and all the points between A and C get mapped to points between A prime and C prime. So we can see that it's a linear transformation there, that it maps lines to lines and line segments to line segments. I mean, that's extremely good news, because think about that. There's infinitely many points here. We wouldn't want to have to construct this infinitely many times. Well, we don't have to. We can just map the endpoints, and then the fact that it's linear transformation says we can just take a straight edge between A prime and C prime to get all the images of all the points between A and C is the line segment over here. Okay? But this is the same vector, whether it's here, 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 here. Same vector. Okay? Now there's some other ways that we can look at some vectors. One way we could do it is by doing some slider text box combinations. Let's put a slider here. Oh, let's say minus 20 to 20. Let's go up in 0.1, let's say. And just it's a number slider like that. Let's give this guy a name. Let's rename it. Let's rename it A, little a. Not big A here, that's the point, but that. And then let's do a corresponding input box here. And A equals, and the linked object is actually A. Okay, and if you have this, you don't necessarily need a label for this guy up here. So I'm not going to show the labels. This is how I like to do these a lot. If that box is a little long, I can go to style here and make it half as long, say. All right, so we got us a nice little box there, and we can actually slide this around and notice that that number changes, or we can just change the number, say to 10, and the point moves as well like that. Okay, so let's do another slider, same idea. Let's put it right here. Again, let's make it about the same, negative 25 to 25, all the same thing. Let's name this one B. Should have just named it at this point. And 0.1 is fine again. And again, let's make a input box to go with that. B equals, and link to B. And why not? Let's make that box a little smaller again and do that as well. Okay, and now we have that. Now what we're going to do is we're going to define a vector that's by these, and let's just name the vector V. So I'm down here in the input box. By the way, if you can't see the input box, you can go over here and go to View and do the input bar. Show that. See, it's gone away now, and it comes back there. Alternately, we could actually just show the algebra view and show everything that's going on over here. Okay, but right now I think it's going to be enough to just see the input bar. So let's do that. Let's do that again. Show the input bar. There we go. All right, now let's define a new vector. Let's just call it v, lowercase v. V equals the vector, and it's going to go from, it's going to move uh, uh, A to the right and then B up. So one way to get there would be to take the origin 0, 0. Let's see if let me see if I can do it this way. I'm not sure if I can do it this way or not. What if I just give it AB? No, it doesn't like that. It'll do a start to end point. So let's do that. Or you can just give it a point and it'll start at the origin. So if we just do one single point, AB, that will give us a vector. This must be the origin of our system right here, and it goes there. Okay, so there's a copy of it starting at the origin. Okay, and what we can do here now is take, say, this same triangle or a different triangle. Okay, let's make this a little bit smaller right now. Let's make this half. Okay, and let's take the same triangle, same pre-image. Let's get a different image though. Let's have it translate by vector v. So we could take this triangle here, again, go to translate by vector, right click and highlight all of this. I didn't quite get all of it. Let's try again. I didn't need to do that. Can't see everything. Okay. All right, let's try this again. Go to translate by vector. I want to get right here. I want to right click and see if I can catch everything. Ah, man, I keep missing. All right, let's try again. I want to try to catch this entire triangle all at once. Let me start here. There we go. I got it all, including the point F. Okay. So now we're going to translate that, and this time we're going to translate by the vector v. Can I do that? Well, I can if I click on the v here. That'll do it. Now it will, as I change A, you're going to see it slide to the right more. And if we change B, you'll see it slide up or down more. So we can basically define this vector here by that. You could either show that vector or not show that vector. Or we can make copies of it going from C to C, to C prime here, or whatever. C double prime, we might call it. Okay, so that gives us another way to do a vector that way. You can also just do this. You can just say translate and give it an object, like say we want to do the segment from A to B, and we want to translate that segment by, say, vector v. Maybe not vector v. Vector v by vector 1, 4. That'll be a vector that just goes to the right 1 and up 4. Translate this segment by vector. Okay. Did that work? Yeah, there it is. It's up there. We went to the right 1 and up 4. I guess the grid is, yeah, now the grid is spaced out one notch each. And we went to the right 1 and up 1, 2, 3, 4. B goes to the right 1 and up 4. Every point on here goes to the right 1 and up 4. All right. So I think that shows you how we can use some GeoGebra commands to create some translations, whether we're doing them from the input line, by sliders. Oh, let me do one more. What if these are magnitude and direction? Okay, instead. Okay, let's go ahead and set that up. So let's set up a slider for a magnitude. Now, magnitude has to be, positive. So let's go from 0 to, 0 to 25 is fine. Okay, so that's going to give us our magnitude. And then we also need our direction, which is going to be an angle. Oh, let's get an input box to go with that one. Okay, and then we need an angle slider. This one's going to be an angle. I have mine set up in radians. You could do yours in degrees. Um, we could go anywhere around the full circle. 0 to 2 pi is pretty good, which is what this is set up to be. Right now it's set up to be start at 45 degrees. That's just where the slider is going to start right there. Again, we can make that's alpha. So I can make an input box to go with that. Alpha, let's see, how do I get alpha? Go here, Greek letters, alpha equals, and the length object is alpha. There it is. Right now it's 0.79 radians, which is 45 degrees roughly. Okay, so now what I want to do is I want to take this and let's start with something fresh here. Another triangle. Okay, and I want to take this triangle and translate it by this thing, this magnitude in this direction. So I want to translate it 2 units at 45 degrees. Okay, actually, let me do it this way. Let me do it by 2 square root of 2 units at 45 degrees, that's what that is. Okay, now I want to translate by that vector. Well, vectors in GeoGebra are given in component form. So what I need to do is create a vector with this magnitude and this direction. Well, we've already studied earlier how we can create a vector like this. I already have a vector v. How about a w? W is going to be a vector, and it's going to go, again, if I just give a point, that'll be a position vector. It'll start at the origin if we show it, okay? And we can just give it one point that'll be the x component and the y component. Well, the x component is the radius or the magnitude, which is c, times the cosine of the angle, and the angle is alpha. Oh, can I get alpha? Where's alpha? I need to get. I've lost my keyboard. Okay, so let's do a workaround here. I'm not sure where my keyboard went. So let's go to here and let's work around by just naming this something that's not a Greek letter. AA, angle A. Okay. So so here we go again. Vector, and it's going to just do like this. The x part will be c times the cosine of AA, and the delta y is c times the sine of angle AA. Now this is going to be vector w, so I'll say w equals. All right, so that will define us a new vector. Uh-oh, it didn't like something. Oh yeah, I'm missing a parentheses. Okay, got to close the sign, close the order pair, and then close the vector commands. Three closes. Okay, that should do better. Okay, like that, this is going to show up over here somewhere. Square root of 2 square root of 2's to the n 45 degrees. See, there it is. One of these diagonals is square root of 2. Remember, this is 1, 1, and then square root of 2 by the Pythagorean theorem. So you're just going 1, 2 diagonals. Okay? And so let's do the same thing here. Let's take this whole thing and translate by that vector W. So if I could take this, so let me just do let's translate, we'll just do it one point at a time. Let's translate G by W. Let's translate H by W. And translate I by W. Okay, and of course once we have those, just take our straight edge or our line segment tool here, click, 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 and we can get there. Okay, so notice each one is going at a 45 degrees, right? Here is our vector going from here to here. Each one's going, well, as it turns out, it's right 2 and up 2, right? But it's 2 square root of 2's at 45 degrees. Every one of these is going by the same vector, right? So this is going to the same vector here. This is going same vector there. Now, once again, the thing that's cool here is you can change it. So these are just going around a circle here as you move this because you're changing the angle but not the distance. And this one you're just changing the distance. So this one's kind of nice because you can see it in motion going from here, and you can actually see the sliding, right? To, you know, wherever it might be, right? And again, change the angle if you want. There it is. There's the original angle we had. And you can see it sliding from there to there where we were and more like that. So pretty cool, huh? So that's how you can get, if you got magnitude and direction, you're going to have to basically convert it to component form, and then you can go ahead and do your translations that way. Okay, so there's an introduction to GeoGebra commands. I think we also kind of saw a little bit about some things that were happening when I started turning on the grid, because you can see a little bit how the grid can help us. Not really all the time, but if it's 0, if it's straight to the right or the left, and you're starting with lattice points on, say, your original pre-image triangle here. Once again, why don't I do that? Do some color coding here to help us out. Help us keep track of what's what. So there's your pre-image, and the corresponding image is going to be over here. We'll make all the image points, come on, red. I get them all selected. Okay, that's a little bit easier to see what's going on. Pre-image and image. If you're just going to the right, then this tells us how much we translate. Like if you want to go just 6 to the right, we can go across. Okay. Now if the angle is 45 degrees, it starts with a degree symbol, so there it is, 45 degrees. Then you can see it's a distance of 6 out, which is not a multiple of square root of 3, square root of 2, but a distance of 6 this way. But you can tell it's going out in that direction, right? If you've got if you're going straight up, then it's real easy as well. Okay, if you're talking about, let's go back over here to the original. Let's hide a few things here. Let's hide a lot of things here. I don't want to hide that. I want to hide this guy. Actually, I want to just delete this guy here. hide these two vectors. Let's see, don't show that. Don't show that. Let's get rid of that. Okay, so now we cleaned it up a little bit. We don't need these either. All right, there was our original based on just on this vector. You can see at least C going to C prime and F going to F prime, wherever it is along this line here. Okay.